Welcome back to the Elemental series of videos. In this video we're going to cover some of the detailed aspects of building a brick wall, in particular concentrating on the mortar and the mortar joints. Now, the structural integrity of a brick wall is contingent on the glue or the stuff that binds it together. Now, the mortar is a mix of I guess fine sand, cement, and usually a bit of lime that helps excuse me, bond the bricks together. Now, there are different types of mortars available. These are set out in the masonry standard AS 3700. Now, the different types of mortars are given a category M1, M2, M3, M4. And the standard describes slightly different mixes within each of those categories, and the ones that we show here are the most typical mixes within each of those four categories I've just listed. Now, the first one is what we call a lime-rich mortar. Now, lime-rich mortars, as the name suggests, have got a lot of lime in the mix. Now, in the standard it says, lime-rich mortars should only be used for restorations where you need to match the material and type of construction. Lime-rich mortars take a longer time to cure, and in more traditional and I guess non-hydrating types of limes, they're often mixed with other fibres such as horsehair and so on to make them stronger. So there is a difference in the types of lime. You can get what's called a hydrated and a non-hydrated lime, and this is the way the difference between hydrated and non-hydrated is the way that they cure. And it is important to make the difference, because I guess if you buy lime from the hardware store, typically speaking it will be what's called a hydrated, whereas for traditional restorations you need a non-hydrated lime. We'll go into this in a bit later. Now, I guess the most standard type of mortar mix is an M2. It has 1 part cement, Portland cement, 2 parts lime, and 9 parts sand. Now, lime is still used in standard mix because the lime makes the mortar, I guess, a bit stickier, which makes it more workable and makes it easier to sort of craft a good brick wall. It slows the curing process down a bit so that the mortar lasts longer and gives you longer working time. So although it's not a traditional lime mortar mix, it is the most common mortar used in most environments except for more extreme, say salty environments or where there's harsh chemicals or under the ground, so that the workability allows you to do a good job with it. Now, an M3 mortar, you'll notice, doesn't have any lime in it. It's got 1 part cement to 5 parts sand. Now, it's often used for concrete masonry, or what they also call a thin bed application, so much finer sort of bed thickness and perpins and so on. It's also used for more aggressive environments and in environments where it's in contact with the sand and soil. Now, the strongest mix is the M4, and again it winds back the proportion so that it's 1 part cement to 4 parts sand. Now, it's the strongest mix, and it's used for sort of subground and sort of in a situation where you might be using strip footings or piers in a particularly aggressive sort of soil types, or in contact with chemicals or so on. Now, being a cement-rich mortar with no lime, it's going to be a very stiff and hard to work with mixture, and it'll go off very fast. So it's not commonly used, only where it absolutely has to be, because the end result is not as good as a mortar with some lime, and there's probably a lot of waste, a lot more labour involved in working this type of material. Now, we mentioned a little bit about the difference between lime and cement. Now, it's important to understand the difference between the types of limes because it's easy to get them confused if you're not aware of the difference. Now, a hydraulic lime is something, it's like cement. It will react, it will cure with a reaction to water. And it's the most common lime used nowadays. So it's a bit like cement, but it just takes longer to go off. Now, a non-hydraulic lime, which is a traditional lime, does not cure as a reaction to water, but in fact cures as a reaction to carbon dioxide. It's called carbonation, so the curing time is much, much longer. So traditional brickwork, which used lime mortar, the process of building a brick wall was much slower because of the way that it would cure, and the strength of the wall would take a much longer time to emerge. So a lot of the sort of intricate brickwork which was done then was kind of predicated on the fact that the lime mortar was different and it was a slower setting material. Now, the other thing with a lime-rich mortar, traditional lime-rich mortar, is that it is partially water-soluble, which means that with building movement and so on, little hairline cracks and that will actually tend to self-heal. So, as a traditional sort of building material, there's a lot of advantages to it, and in terms of, you know, buildings moving and aging over time and self-healing, but the practicality of using lime in a sort of a time-poor environment means that it's basically gone out of fashion. Now, a cement basis to mortar means that the reaction will go off with water. It will cure quicker, and it means that a cement-rich, I guess, a cement-based mortar means for faster working time. The cement gives it, I guess, more of a build or stiffness, so it is actually better for bridging and adhesion. So again, it just depends on specifically what type of situation you need it for, whether you want a stiffer, sort of faster cure, or something that's slower but a little bit more manageable and malleable. Now, the other ingredient in, I guess, the aesthetics of a brick wall is the colour of the mortar itself. Now, there are plenty of pigments that you can use to add to the cement, which will end up colouring the mortar. So sometimes you can use a contrasting colour mortar, and sometimes you can try and blend the mortar in with the colour of the brick itself. Now, the cost of these admixtures to the mortar itself is not a significant overhead in the overall scheme of things, but it is a difficult thing to manage with mortar simply to try and keep the colour consistent, and that's, I guess, the biggest problem in it all. If you can get pre-coloured mortar that is batched so that the consistency is managed in a more sort of controlled environment, that's a more ideal situation. Putting in the oxides yourself in the mix of the mortar is a risky proposition, which is why it's not done very commonly. Now, looking at the joints of the mortar, that again is another sort of type of expression and also another aspect of the durability. Now, I guess two of the more common types of joints and brickwork is a rake joint. You can see it's on the left-hand side here. Now, a rake joint is achieved by just a smooth steel dowel, which is then ironed or pressed into the mortar as it's going off, and that sort of compresses it and sort of gives a nice finish to the brickwork itself. The other option is to get a tool with a sort of a small nail hole, nail poking out of it, and then to run it and to sort of pull out or scratch out a layer of the mortar down to a depth of probably 5 millimeters. Now, this won't give you as smooth a joint, and inside the joints are a bit rougher, but it does give a little bit more articulation to the brick itself. The other two joints, which are perhaps less common, is what's called a weather-struck joint, where it's ironed with a flat tool and sort of pointed inward, so that it's always weathering to the outside, so it's draining moisture away from the wall. This it takes more time, and there is a lot more sort of skill involved, but it's perhaps one of the better joints to use. The other is a flush joint, where it's just sort of ironed out flush. Now, the tricky thing with this one is it tends to be a bit messier than the other joints, which is why it's perhaps not favoured as much. And one of the biggest problems with brickwork is cleaning them afterwards. So anything you can do to avoid putting too much extra sort of cement or mortar on the brickwork is always going to be better, which is probably why flush joints aren't very popular. Now, hopefully that gives you some insight as to the, I guess, the added part of the equation, which is the detail parts of bringing the wall together. Now, the standard AS3700 is the global standard for masonry, both clay-based and also concrete masonry. It's a very technical standard. It's probably good to go through and have a look at it. We've just made some specific reference here as a sort of a dabble into it, though we've dealt with most of the other aspects of clay-based concrete masonry on a more sort of generic and principles-based. So hopefully you've got something out of the series of videos, and the videos that will follow will deal a little bit more with concrete masonry and heavy wall construction.